kind of conference. But I'm a little impractical in my talk today. Today I want to give you food for thought, and my hope is that this way of thinking will help you when you're developing your own mobile applications. So that's really my non-ambitious goal for the day. So the talk is called The Bubble. So, a question that may arise is, what is the bubble? So for me, the bubble is a simple thing. It's where people go when they're using mobile applications. So that to me is really important. Now, what I'd like to compare this to is the concept of cyberspace. So what happened early in the birth of the internet is there became this word that people started to enjoy, and they started to say, I'm going to spend time in cyberspace, right? So what does that mean, right? So cyberspace is a location, and it's a non-geographic location that people go when they're using mobile apps that is different from cyberspace. And my question is, why is there a need for a difference? Well, I think there's two major differences. The first difference is that the bubble is not necessarily a non-geographic location. So when you're on the internet, it doesn't matter where you are. But when you're using your mobile device, there's GPS and there's a lot of context that you're sitting in some location with a physical body, and that may make a difference. But the second reason why I think the bubble is an important metaphor beyond cyberspace is that what we've done with the internet is we've shifted to an entirely different dimension of users. And so, for example, we developed at Key, we developed an app called Key Safe. And Key Safe was basically a media privacy app. So, the purpose of Key Safe is people can hide pictures and videos on their phone from, people they don't want to see this stuff, right? So we got to about 1 million downloads, and we ended up spinning this company off to become Keep Safe. We changed the name and we spun it off, and now that app is at about 10 million downloads. So, again, riding that huge exponential curve. Very exciting for us. So to make a long story short, though, I worked on the help desk for this app, and not because it was a very good use of my time, to be running a help desk, but I have to say the mentality of the user base was really interesting, which is that I'm used to technology users being computer nerds, and really sophisticated. So what is being reached with the expansion of 1.7 billion smart devices dropping onto the earth is that within a few years, within 2017, it's projected that there will be more smart devices on earth than there will be humans, which is a little strange. But, be that as it may, we're entering a phase where the user of technology is operating at not nerd sophistication level, right? So this to me means this concept of cyberspace has a feeling that's much more technological than the bubble. And I'll talk exactly about the psychology of the bubble as I start to explain more about what it is. But for now, just suffice it to say that the bubble is just a place, and it's the place where people go when they are using an app. Just to kind of put a final capstone on this, people enter into this bubble because they prefer to be in the bubble as opposed to being wherever it is that they are. And so they continuously have an option to be inside of the bubble as opposed to being where they are. So for example, a great place to observe this phenomenon is on public transportation. So I've ridden on trains and buses and various, all over the world. And what you notice in any place, if you're in Seoul, Korea, and you're riding the train, people are inside of the bubble. Now in Korea, people are watching videos. This is important. And the reason why the bubble is important from an application user experience design perspective is that you want to know the psychology of the user from the perspective of engagement. So to me, engagement is a meta metric for application developers. Now, the reason why I wanted to have this slide is because measurement is absolutely key for the way that mobile applications are developed. So what are the measurements that are really important? So obviously, user acquisition. So I mentioned user acquisition is critical. Retention is critical, and you may want to use 7 or 14-day retention as a proxy for the retention of your entire base. And in fact, if you look at how Facebook measures user acquisition, the term user acquisition internal to Facebook is actually an aggregate statistic that lumps together acquisition and retention. Because to Facebook, a user that's not retained is not interesting, right? So, all of their drive to grow user base is connected to retention. So obviously, user acquisition, retention, but engagement. What's the second reason why engagement is such a critical factor? I think engagement is a critical factor because it drives monetization. As we move towards this kind of attention economics within the app environment, the more the users are opening. So one of the sub-measurements within engagement is sessions, right? So you can say how many sessions per day. You can kind of understand when the users are opening sessions. So you can statistically cluster app opening times. And then the other engagement statistics that are important are session durations. So all of these measurements and statistics, these are things that this particular slide is just a picture of the key cloud backend service where we maintain analytics of all of these types and as well custom analytics for apps. So, within this context, we want to drive engagement, and the engagement is driven by a better understanding of the user and what the user is wanting. So why is neuroscience an interesting lens with which to look at mobile app engagement? So why is that an interesting lens? To me, what's happening now is a unique phase in human-machine coevolution, which is, to me, what's happening is this perfect storm of platforms, right? So what you have is the emergence of the cloud, which provides this kind of non-linear scalability of back-end. And then you have this mobile thing, which is happening, which is providing non-linear user adoption. And in fact, the adoption cycle of the mobile technology is faster than all the preceding technology adoption cycles. So television, radio, print journalism, all of these different mediums as they evolve. So this is extremely fast adoption. But what's happening is that if you look at the adoption of technology today is more related to the design of the user experience as it hooks to the emotional experience of the user, right? So one of the ways you get exponential user growth is by hooking the user's emotional experience. And I can tell you definitively that the user's emotional experience is 100% governed by evolutionary principles. And why is evolution interesting is that the brain has a purpose. And the brain's purpose is distinct from your purpose, which is the brain's purpose is survival. The brain is a survival engine. And it's pretty easy to see why that is. The previous, one of the previous keynoters today talked about going back 14 billion years. So I'm not going to go back that far, but I will rewind back about 1 billion years just to recapitulate some of biological evolution. And if you really look at the birthplace of the nervous system's function is essentially to detect food, to process threat, and to respond to acquisition of nourishment, protection against any possible threats. And then the third one obviously is to pursue reproductive opportunity. So those, I'm going to talk a little bit more about the survival engine component of the brain and how the survival component links to the emotional experience of the user. So that's really important. So if you're designing an application, you need to understand that the brain is trying to survive, and that if you can simulate those kinds of functions, then you can gain engagement, right? So something as simple as Angry Birds produces an emotional response that creates engagement with users simply because it's recapitulating a system within which the brain evolved, which is it's recapitulating a system of survival and attack and defense and all of these kinds of mechanisms, right? So, it also plugs into gamification, which is also has a neurological substrate. So, going back the 1 billion year, and when I talk about 1 billion years of evolution, we're talking about the beginnings of the first nervous systems, right? So this predates, obviously, anything that remotely resembles humankind. But the thing that's really critical to understand about the brain is it is an evolved IT system, right? It's an information processing system, and it's built in layers. So probably one of the most kind of classical views of the brain is this context of the triune brain, which is, and everyone's already heard this model. It's very old, right? Which is this notion that there's a reptilian brain at the very base, which is medulla oblongata and cerebellum and the pons, brain stem, to some extent motor cortex, and that these functional components in the back of the brain are functionally autonomic, and they split into sympathetic and parasympathetic units. The sympathetic units are responsible for fight and flight behavior is engaged by things like gaming. The other behaviors that it engages are things like rest and digest, which is the parasympathetic response. So all of the autonomic system, it's kind of reasonably not terribly interesting from a mobile application engagement perspective, but suffice it to say that each layer is built on top of the previous layers. And so I think from a neuroscience perspective, it's important to understand that these functions have grown evolutionarily over time. And that the two principles of evolution that apply here are, first of all, conservation. Like, evolution is extremely conservative. And I want you to also think about this from an IT systems and platform perspective, which is a platform is a code base that is highly conserved, right? And it's highly conserved because it's the basis of things that many users like to use. If you look at biological evolution, you can see DNA sequences like cytochrome C. So cytochrome C is a sequence that exists in all known organisms, and it's highly conserved, right? Very similarly, it's important to look at platform and architecture as these types of pieces of code. So the question then becomes, what are the highly conserved pieces of the brain and what functions do they supply? The second pattern in evolution that's very important is variation, which is how does random mutagenesis and speciation create tremendous variation and vitality? So I think this is an important evolutionary principle here. So, if you look at it from an evolutionary perspective, you can see that the brain forms a stack diagram. So the stack diagram involves, obviously, this brain stem and each layer that comes up from, the bottom to the top. So I'm going to build the stack of the brain. Now, getting back to the original theme of the talk around the bubble, we're going to get to the bubble when we reach the mammalian layer of the brain. So we're starting a little bit lower in the form of the primitive brain. So I actually referred to some of these processing threads. So if you look at these threads, what you can see in this stack diagram is you can see that I've set up different kingdom, phylum, and order mechanisms in order to classify the commonality of conservation. So for example, if you look at this layer of the brain, you're talking about having the same layer in common with all animals, which is this notion of these three primary threads. what's common is this notion that you're threat processing. So one of the things that I want you to think about is that threat processing is a little bit more abstract. It's a little bit more abstract than just gaming, right? So, for example, one thing that people look at in threat processing is things like news applications or weather applications. So it turns out that weather applications are extremely sticky and also extremely engaging in the App Store. And one of the things that people are doing with weather applications and news applications is their threat processing, which is they're effectively and to some extent compulsively connecting to these applications just to make sure that nothing environmental is going to come and eat them, right? So, this is I want to make sure that that's well categorized and classified. Obviously, nutrition is a major function, and you can take it either literally or you can take it figuratively. Like, for example, if you take it literally, there are very engaging applications that help you find restaurants. So you're literally finding nutrition, you're finding food in your environment. But for example, if you take it up a level of abstraction, you can find that there are certain applications like, for example, like Groupon, or finding good deals, right? So the act of people looking for things to buy that are a good deal, so any kind of shopping activity is connected to this concept of hunting for nutrition and finding something that's great. Like, oh, I found a piece of fruit, or I found something nice, right? So this kind of questing and seeking behavior is intrinsically tied to this type of, desire to create nutrition. And then obviously the third one you can think of very literally as well, which is, there are dating applications that are about mate selection and finding reproductive success. But I'm going to build a case later on that the brain is capable of extreme abstraction when it comes to things like the reproductive impulses. So for example, even just vanity behavior in a social context like Facebook could relate to a psychological impulse to be attractive, right? To be cool, right? So a lot of the behavior around apps like fashion apps and apps where people are trying to look good to other people, this may relate to display, and it may relate to the kind of reproductive impulses that you see in other species. So, this is a bit of a gimme, and I showed the same slide in my keynote earlier, right? Which is, if you look at the world according to Pac-Man, there's reproductive and nutritional as well as threat processing targets. I do want to say, if you look at these limbic threads as processing threads, the threat processing thread is actually the primary thread. It can interrupt all other threads, right? So you could be having a perfectly nice meal, and if a tiger comes into the room, you'll probably stop eating, right? And the same thing could be said for reproduction. You could be engaged in a perfectly normal reproductive act, and a tiger can come into the room, same result. So to make my point, the threat processing thread has an interrupt hook over all the other threads, which is why it's a really interesting one to look at from an engagement perspective. So, again, this is the same kind of point that I was making a little earlier, which is I don't want the people here to think that this is only interesting for game apps. Now, I do want to say that in engineering, designing, and architecting user engagement, you do want to think about gamification of non-gaming apps, right? And that relates to higher order functions like collection and completion and things like the endorphins that are released when you solve puzzles, so you feel clever. So all of these kinds of mechanisms within the gaming world can be engaged in non-gaming apps. But I also want you to think about these kinds of apps like news and weather and shopping and these kinds of things. And to me, the insight that I want to impart is that all of consumer behavior can be attributed to this kind of brain function, right? That the brain functions are generating behavior, and that as you go further back through the layers of the brain, you're getting closer to the centers that generate physical activity, like pressing buttons. So I want you to just think of it from this framework. I'm going to talk about the neocortex a little bit later, but what you'll realize when I speak of it is that the thinking part of the brain represents such a small amount of the biomass of the brain itself that it really shouldn't be considered all that significant. And I think this is one of the biggest shifts that I want people to make when they're thinking about applications, and not just consumer applications, but when they're thinking about applications and the expectation that applications produce. The reason why I think it's important to think about the expectations is this trend called the consumerization of IT, right? So Gartner picked up on this trend maybe 3 or 4 years ago, but the general pattern is that people are very interested in getting consumer-style applications. So even when you are building an enterprise app, the expectations of the user is that this will feel and act like an app that comes from the App Store. So I think this kind of mechanism is very important. So as you can see here, I'm pointing out that the phylum of Chordata, or organisms that have a spinal cord, have common systems, including the limbic system that I described. So that's an important principle. So when I talk about the limbic system, there's a couple of structures that I want to point out, but this one's very interesting, which is the amygdala. So the word amygdala is actually Latin for almond, and in fact, if you look at the size of it, its size and shape is approximately almond-like. It's very interesting. This is just a totally gratuitous aside. I just want to you to indulge me, but in Patanjali Yoga Sutra, he talks about this concept of samskara, which is this concept of basically patterns of behavior that are ingrained because of your conditioning. So it's conditioned behavior. And he says that these conditioned seeds of behaviors called samskaras are basically rooted in your consciousness, and that these seeds sprout into kind of patterned or conditioned behavior, right? And the metaphor that's used is, this is not directly in Yoga Sutra, this is in the commentary of Vyasa. He talks about almonds. And the way that you stop almond seeds from sprouting is you roast them, right? So he's basically proposing that you can roast these almonds and it produces better resulting behavior. All right, so that was very self-indulgent. But talking back about the amygdala processes a lot of emotional response. It processes kind of, for example, one of the face recognition pathways goes through the amygdala. And when people recognize faces, part of the function that they're doing is they're actually looking to see if that face is angry. Because if the face is angry, then it can actually trigger the threat processing, right? Or if the face is scared. So if a face is scared, then that pathway of face recognition can then pick up that, okay, maybe there is a tiger in the room or something of this sort. So that's very interesting. And there are also some sexual behaviors that also are processed through this very important brain component. This is another important brain component, which is the striatum. This one is also present in birds. The birds actually don't have a neocortex, they have a hyperstriatum. So they have a mechanism that evolved above the striatum that allows them to do things like generate birdsong and generate reward behaviors. So birds are actually trainable as a function of the striatum. So I think what's important to look at from a gamification perspective is that reward behavior, collection and completion, persistence of behavior, motivation of behavior can be tied to these repetitive patterns. This is really important because one of the things that gaming can do, or gamification can do, is it can create addictive behavior. Addictive behavior in mobile applications is important because ultimately what it can do is drive retention. So I'm excited about the ability to engage users in this way. So this is a slide from a friend of mine who runs a consultancy called Zio Designs. This consultancy works with Electronic Arts, it works with Blizzard, Activision, it works with all the big gaming companies, with Microsoft, and she's developed a model for gamification. If you're interested in kind of understanding more about gamification, I encourage you to look at her website. It's XEO Designs, zeodesigns.com. And she actually has a general model of gamification that composed of these 4 different kinds of fun, right? So, these 4 kinds of fun are curiosity, amusement, what she calls hard fun, which is challenge and excitement, and relaxation, which is what she calls serious fun. So just a little side note on gamification. So this is where we enter into the bubble, which is that the mammalian brain is essentially an emotional system that's evolved as a function of being high investment mammals. So one of the things that's really interesting about developing as a social primate is that we all have parents and that we're extremely high investment. If you look at fish, for example, fish are pretty indifferent to their young. So some of the fish eat their own young because statistically it's not that interesting of whether they've done so or not. Human beings historically don't eat their young, except in ancient Greece and some other places. But I'm just referring to the mythology. There's a lot of people and gods who eat their kids in Greece for some reason. It's not actually that much happening. But if you look at infants, they are unable to intrinsically process threat information. So what's really interesting about how this manifests is that they use maternal reflection as a way of processing threat information. So when something threatening occurs, they don't have a mechanism to identify the threat. They always look to the mother to process the threat. So the threat coprocessor is the mom and the mom's database of experience with tigers and other threats. And this kind of comes into this concept of the bubble. So one of the things that you see in the gaming world and in the entertainment world in general, this is from the movie The Incredibles. So the sister in this movie is capable of forming an indestructible bubble around herself. This is from the World of Warcraft. In this game, some characters are able to form an impenetrable bubble around themselves. And this is from the Super Mario Galaxy game experience, which the characters are able to form an indestructible bubble around themselves. So what is the nature of the indestructible bubble that they're forming around themselves? This is essentially a threat processing response, which is the notion that there's this invulnerable shield that can be used to protect a person from threat. So it's interesting because psychologically, when you look at this indestructible bubble, there are psychological threats. So, for example, if you're standing in line at a bank, your time is not that important because you're just standing in line, and so you want to enter into a different space. So the space that I'm proposing that you're entering into is this bubble, which is a place where you're protected and that you can't be insulted or interrupted. You're just here in a nice spot. So in human evolution, and in the developmental psychology, there actually is an experience like this. And this experience of being in the bubble is basically being in the womb, right? So in a sense, as human beings progress in the world, they're basically inside of this womb-like environment. How does this connect back to the importance of different dimensions of application design? One thing that is absolutely foundational that you should never miss is that the applications should never crash, right? So one of the things that's become extremely critical in application development is crash analytics, because you want to know exactly which model crashed and how did it crash and why did it crash. And the reason why crashing is such an important behavior is when the application crashes, you've broken the bubble. And the user is taken from their beautiful environment in which they are invulnerable and protected from harm, and they are thrust out into the cold, cruel world, right? So you want to make sure that you have integrity of your application. So I suggest Crash Analytics. The Crashlytics product is actually a perfect example of that, and you should maybe consider that SDK. And I actually have a blog post about this, which is, when you look at threat processing and nutrition, and if you study, Freud, reproductive selection, the ultimate user experience, I have a blog post on Miko.com about mom as the ultimate user experience. So if you look at what nerds continuously try to reproduce, they try to reproduce the computer on the original Star Trek, which is someone who you can talk to, who will take care of things, who knows everything, and who will protect you. And in fact, if you look at the Star Trek, the Enterprise, the Star Trek computer is capable of surrounding the ship in an impenetrable bubble. Well, it's penetrable, but the shields are supposedly a good defense system, right? So, what happens in mammalian terms, though, is that you gain additional layers of complexity. For example, you gain questions like, not just can I eat it, but will it protect me? Another thing is, will it groom me? And will it nourish me? And this is another layer of importance in the social level. And obviously, this starts to plug into things like face recognition. Face recognition is getting increasingly sophisticated. Facebook has algorithms that say things like, is this a face? Right? So when you look at a Facebook picture, there's a box around faces. And it says, this, in fact, is a face. It's useful, right? But as we start to get more sophisticated, algorithmically, we start to get more data about the face. Whose face is this? That's a very interesting, Facebook acquired a company called Face.com, whose algorithms are primarily oriented towards identification of faces. Those applications are increasingly going to integrate with Google Glass, which, by the way, is another form of bubble. It's immersion inside of this bubble environment. So this algorithm that I'm showing here is the Fraunhofer face recognition system that allows you to identify emotional patterns. And one of the really interesting things is it's able to do things like segregate real, quote-unquote, real emotions from fake emotions. So whether a person is smiling because they're happy or because they think they should smile, this algorithm is able to kind of start to attempt to differentiate these expression patterns. I have this whole fantasy about autistic kids who have trouble recognizing facial emotional patterns using a prosthetic emotional facial recognition system to be able to function more normally in society. So these technologies, I think, are very interesting and emergent. And of course, the next layer above just being taken care of as children is this entire social architecture and infrastructure, which is, it turns out that people's tribes feed them, they protect them, and they find them reproductive partners. And so these villages and tribes that form are directly related to human social behavior and things like the Facebook context. And, one of the things that happened to me, this is my Pinterest. So you're now kind of looking at the inside of my brain. It's a little embarrassing, but there you go. So what happened? So one of the things that I initially started to do is I started to get focused on food. So in Pinterest, I'm really interested in looking for recipes and exciting things that I can eat, right? And so I did a search for broccoli. I was very interested in broccoli. And suddenly this guy showed up, this little gray bunny rabbit. It turns out that his name is Broccoli. Right? And so I clicked on it because I was like, hey, that guy's cute. Right? So I really like this bunny rabbit. So I clicked on him, and next thing you know, more and more cute animals started showing up on my page. So this tells me something, which it tells me that there's something in my primitive behavioral brain that connects with protecting cute things, right? And that this may actually be a mammalian thread that's processing at a very primitive level. And you know, there are like attractive women that appear on this page as well, and that's also another one of those, hey, that's interesting, and then suddenly Pinterest is like, oh, okay, here you go, like giving you this kind of information. But again, Pinterest has become ragingly adopted and ragingly successful, and you can actually see how these mechanisms are connected to that. It's not strictly a mobile app. If you look at human factors around social behavior, you know, Robin Dunbar, social psychologist, said that human beings are capable of processing about 150 social relationships. If you look at how Facebook has increased that number, people, how many friends do people have? They have hundreds or thousands, you know, it's pretty amazing. But if you look at the technologies that are applied, that's a critical gating factor. If you look at social behavior among non-technological, you know, social primates, you find that the number drops to about 67 or so, because they form relationships by grooming. And the grooming behavior is limited to a certain number of other primates, etc. But this is kind of an interesting foundational insight about human social behavior. And I already kind of mentioned that the kind of face recognition and emotional reactions are connected in through the amygdala. So I just wanted to say, so I mentioned this earlier as well, which is the neocortex, which is the seat of reasoning in the brain, is about 6 millimeters thick. So it's just a very thin layer. So in case you think that the intellectualization component of mobile applications is important, you know, it's probably not that important. So, you know, don't worry too much about the data inside the app and the user's experience of that. It's more about engagement of the back end. So this is kind of another important object, which is the hippocampus. So the hippocampus, that literally means seahorse in Latin. It's supposedly shaped like a seahorse. I don't really see it myself, but it's this kind of curved structure. So the hippocampus has bilateral symmetry, and it's responsible for essentially long-term associative memory. So it's really that matrix of interconnections. One of the things that you may notice too is that the sort of structures responsible for memory is related to the rhinonasal cortex function of smell, right? So it's why, for example, when you smell something, it instantly connects you with other memories, because the physical structure allows for the proximity of those afferent neurons to stimulate those different parts of your brain. But the associative memory part of your brain is extremely interesting because it allows you to build application interest by connecting with associative memories that the user has. And this is part about being like a sapient human. So this has been kind of a nice sort of night's tour through the human brain from the perspective of application engagement. I do want to just close by encouraging you all to, you know, think hard about your application from this behaviorist perspective. Think about it from the perspective of, hey, what kinds of behaviors am I tapping into, and what are the root patterns of those behaviors? Why do people behave this way, right? Because in doing so, what you can do is connect features and functions within the application environment to the kinds of metrics that matter, which is user acquisition, retention, and of course, most importantly, engagement. I do want to just make a quick note, which is, you know, I'm here representing Key Corporation. We have a mobile backend for application developers. So if you're building cloud services for your apps, you can create a cloud application for free within your app within minutes rather than months. It's extremely fast and efficient. You can go to developer.key.com. Also, if you're curious as well, we do have a contest where there are almost $50,000 US worth of prizes at key.challengepost.com. And so, you know, Key, you can basically develop these kinds of mobile backends very, very rapidly and without writing any server code. So I just wanted to mention that. I'll be doing a keynote tomorrow at the Java event, so hopefully I'll see some of you there. Thank you very much.
Perspective, I think. Have
Yes.
there been studies conducted in terms of behavior patterns for children, say in the range of 3 to 8 years or something like that? So how do they behave, and what is the considerations that you typically take in case of apps that cater to that?
Yes, yes. So children behavior is foundationally different because you're dealing with a different brain. It's actually foundationally different. You can look at the studies of Piaget, who studied child development, and there's a certain specific age where you see something like the emergence of volume constancy. So for example, you can take a liquid, a colored liquid, and you can pour it into a very funny spiral device, or just a flask, right? And in a flask, the color, the size of the liquid appears to be like this, and in the other objects, it appears to be big, right? And so the thing that's interesting is below a certain age, children will say there's more liquid. And you can even pour it in front of their eyes into these different shaped vessels, and the kid will say, oh, that's more, there's more liquid, and then you pour it into this other one, okay, there's less liquid, right? So that concept of volume constancy is age-gated, right? So I think, given that as an example, so for example, even things like I talked about mate selection behavior, right? I mean, unless you're a hardcore Freudian, that's not going to be relevant at that age. So without giving you a complete answer, I do think that it is important to look at children as effectively alien intelligences because their brains are fundamentally differently structured to process information differently. For example, they don't have their own threat processing primarily. They're mostly cueing off of face pattern recognition. But the thing that you want to take from that is when you look at newborn infants, one of the first things they're able to resolve is actually faces, opposed to geometric shapes of any other kind. So it's a very, very interesting species adaptation, because I'm almost certainly positive that fish don't see faces first. Children do. Any other cues? Which governs all productivity apps, right? And all productivity can kind of fall into these various impulses, like, for example, the social layer, right? Or people are looking for recognition, they're looking for advancement in their career, and they're looking for kind of that display of their prowess or their power, right? And so that emergence of the work impulse is something that relates to how people connect to society. But what I'd rather have you think about is more along what's important to each individual app. So for example, in an individual app, you may want to have like a certain number of things you need to collect. And that way you can kind of engage collection and completion behavior, which is more tied to kind of the striate cortex and kind of gamification of how people, want to have a certain number, or they want to fill a certain number of boxes and this kind of thing, right? So to me, the more important lesson around productivity applications is how can you look at the individual features of the application and how they tap into different kinds of brain impulses, right? Rather than the whole category of application. I think we're probably close to time, but I'll be around today and tomorrow, so feel free to stop me if you have an interest. Another question? Yeah, one question. The other thing I wanted to note is I'm available at Miko Java, which is my Twitter, and if you want to email, I'm at miko@miko.com, M-I-K-O, and my website is miko.com. So if you want to grab me, I'm accessible.
Okay. The question I want to ask is, what are the core emotions we should be thinking about for a proper LOB application, line of business application?
Yeah, the emotions related to kind of proper line of business. So typically the emotional reactions that people have around applications tend to be very subtle, right? Particularly kind of business applications, right? So, you're not necessarily going to get like fear, right? Which you get more in like a gaming application where you feel like you're running away from monsters or something, right? So to me, what's really important is to look at things like the reward response. So people get kind of a dopaminergic and endorphin-mediated happy response, right? When they achieve things. And this is very closely related to kind of the classic field of gamification, which to me is really just programming brain APIs. Right? They're programming the platform of the brain, and the function of gamification is really just knowing that people work a certain way and that you can really hook them by working the way that they work. So
you didn't cover the dopamine side of it in this
Yeah. When you look at the striate, so the question was, I didn't cover the dopamine part of it. Yeah, so if you look at the slide on the striate cortex or the striatum, it does talk a little bit about this dopaminergic pathway, which actually connects with things like obsessive compulsive behaviors. And so this kind of reward loop, there's an entire field of study now that's not gamification called habit formation. So if you guys want to Google up habit formation, it's very, very interesting, because when you look at business applications, one of the things that's important to kind of help people engage with is the habit of using your application. And you can use mechanisms like creating habit chains. So you can say, you have used my application every day for the past 7 days, I'm going to give you a star. And these kinds of mechanisms allow people to habitually use your app, which I think is a very powerful form of engagement. All right, so I think we're definitely on time here. So, thank you very much, and hope to hear from you.